Hi everyone, this is Sunny Kumar from IIT and welcome to my channel Code with Sunny, and today I am going to discuss the problem keys and rooms. Index number is 841 and the problem is of medium type of Leetcode. So let's discuss the problem now. In this problem we have been given n rooms and you start, that is we start in from room 0, okay, and each room has a distinct number associated with that, that is it is going to vary from 0 up to n minus 1, that is the room number, and each room may have some keys to access to the next room. Okay, so it basically means that from a particular room I, let's say, we can jump to any other room if it has a if it has a key of that room. Okay, so more formally, each room I has a list of keys, that is rooms of I, and each key is going to denote is an integer, that is from 0 to n minus 1, where n is also the room's length. Okay, a key rooms of ij is equals v when opens the room with a number v. Okay, so initially all the rooms start locked up except for the room 0, so we are going to start with the room 0, and you can walk back and forth between rooms freely. Okay, and return true if all the rooms are visited. Okay, so this was the question, and there are two examples given. And also let's look over the constraints. That is, room's length is going to vary up to 1000, and rooms of I dot length is also going to vary up to 1000, and number of keys in all rooms is at most 300. So how we are going to do this problem? So let's move further to analyze the problem too. So suppose here are the list of you can say rooms, that is 0, 1, 2, 3, that is 4 rooms starting with index 0, and each room I have written the keys associated with that, that is for the room 0 I have the keys 1 and keys 3, and for one room with ID 1 I have the keys with 3, 0 and 1. It means that from a room 0 we can jump to room 1, and from room 0 we can jump to room 3. Similarly, from room with ID 1 I can jump to room ID with 3, and also from room 1 I can jump to 0, and also from 1 I can jump to my room itself. Okay, so this basically denotes a directed graph. That is, if you can understand this orientation, this is nothing but a adjacency list of a directed graph. So let's build the directed graph first. Okay, so this is basically 0, and from 0 you can go to 1, and again you can go to 3. Okay, and now from 1 you can go to 3, 0 and 1. Okay, 1 you can go to 3, and from 1 you can go to 0 also, so I'm going to write like this, and from 1 you can go to 0 and 1 itself. Okay, so I'm going to write like this. Okay, so it is basically a graph, that basically a node pointing towards itself. Okay, so from 2 you can go to 2 itself, you can see. Okay, again you can go from 2 to 2 itself, and also from 3 you can go to 0. Okay, so I need to start from the root, that is from node 0. I think I've taken some mistake, or it is fine. From 0 I'm going to go 1 and 3, and from 1 I'm going to 301, and from 2 I'm going to 2, and yes, it is fine. Now you can see I have to start from the node 0. Okay, and I need to check if from starting with node 0, if I am going to traverse all the nodes of this graph for using this adjacency list. If it is yes, I need to return true, otherwise I am going to return false. So if I am going to start with 0, I can reach to 1 easily, I can reach to 3 easily, and that's all, because 0 is visited, 1 is visited, and 3 is also visited, but you can see 2 is not visited yet. Okay, so in one DFS traversal, that is depth first search traversal, you can see I haven't visited the node 2, that is room with ID 2, so it means that I have not visited the entire rooms, that is all the rooms, so I need to return false here. So what about the case, it is like when let's assume 2 is connected with that, that is 3 is connected with 2 with a directed graph edge pointing towards 2, that is here I have 2 added with it. Okay, so from room ID with 3 I can jump to room ID with 2 if I have the key of 2, that is room, I have a key of room ID 2, so I can jump from room ID with 3 to room ID with 2, that is the graph, directed graph pointing from 3 to 2. So in one DFS traversal, you can see I have come from 0, then go to 1, then go to 3, and then go to 2. In this case, you can also have traversed all the nodes. So it means that our answer will return as true. So that is the basic approach of this problem. So let's move further to the coding part. Okay, so I need to write here, I need to implement a DFS function as obvious. So I'm going to write, okay, so I'm going to write one thing. So let's write a DFS function void DFS and intv, and let's have a visited vector bool and visited, and let's have the entire this adjacency list of rooms, that is nothing but vector of vector int and rooms. Okay, that's fine. So I need to do one thing, visited of v is true, and then I need to traverse in the adjacency list. I think I should have write okay, rooms of v, and if not equal to visited of u, simply visit that vertex. Okay, I think this is fine. This DFS function is fine. Now I need to declare a first I need to write down there as rooms dot size. Okay, so let's define a visited vector over here that is going to check if the current vertex is visited or not in the DFS traversal. Now I need to traverse the DFS function starting with 0. Note that only room 0 is opened at initial, that is initial or given data. Okay, so I need to start with room 0, and I need to pass the parameter as visited, and I need to write as rooms. Okay, so again if I need to write if count of visited dot, okay, so I need to write count of vis dot begin and vis dot end. I think I should have to count false, and if this count of false is going to come, then what should be our answer in this case? So I need to write if there is a false, then I should return true, that is sorry, return false, that is our answer can't come up because haven't visited some vertex, otherwise I need to return true. Okay, so I think I should submit this code directly. Okay, because I have some compilation error, I think. Okay, so I need to declare here of type bool. Okay, so let's now run this code for simplicity. Okay, so accepted. Okay, so okay, so yes, it is good, faster than 95.02% of online submission. So if you have any doubts, do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.